Section 7.6. We're going to talk about dot products. What dot products are is a number to help us deal with vectors. It has some uses that we'll probably really won't get to because they're kind of beyond the scope of this class, but you need to be exposed to what it means so that you can use them in the future. If we have two vectors, remember, we're using complex numbers. We're using vectors to represent complex numbers, but it doesn't always have to be that way. So if you have these complex numbers, remember, this is all the three ways we know how to write it. We have these two vectors, u and v. Then the dot product is this formula here. U dot v is equal to the length of u times the length of v times the cosine of the angle in between, if they're both set with their tails on the origin. We're looking at that angle between them that way. So that's our formula for the dot product. Now, in your book on page 375 here, you've got a representation of this. Now, the dot product's an operation that matches two vectors to a unique real number. You can read that. And the dot product formula can be written in terms of the real parts and the imaginary parts. So here's the formula. Now, we can use the formula in different ways. We can, let's see if I can go up to the next page, the page before. Nope. All right, so we can look at this. If we have these two vectors and the angle between them with their terminal points both at the origin, or their initial points both at the origin, if we represent the vector that joining their terminal points as x, then you can see that u plus x equals v. So here's our u plus our x, and that equals v. Because remember, we said if we were adding them, we had to put the tail of the second one onto the head of the first one. So if we have u plus x, then that gives us our v. Now, that means, if we just rearrange this a little bit, that v minus u is x. Because if we have u plus x equals v, then subtract the u on the other side, and you have x equals v minus u. So it makes a triangle, and we can use the law of cosines. Remember, the law of cosine says the length of one side squared equals the length of the other side squared plus the third side minus 2 times the second and third times the cosine of the angle between these two. So that's our theta here. This is the angle between the two. So we use our law of cosines, and then we just rearrange things. So we have our length of the v minus u squared minus the length of u squared and minus the length of v squared. And then we have equals negative 2, divide by the negative, and then divide by 2. We have this u, v, cosine theta. Well, that's what we just said was our dot product. Okay, so because we have this dot product, hopefully you can still see this when we go down. Because we have this is the definition of the dot product, we can replace that there. Now this gives us another way to calculate the dot product if we don't know the length of u, the length of v, and the angle between it, because a lot of times we don't know the angle between them and we just can get our lengths. So we can use this formula here. Well, what is this formula? Well, this v minus u, the length of that, is the distance between our AB and CD, because it's the length of this vector here. So that we use our distance formula, and we use our definition for the length of u and v here, and substitute all of that in here. So what they're doing is they're taking distance formulas to replace these magnitudes of the different vectors here, replacing it all in, multiplying it all out, simplifying it all, and in the end you have AC plus BD. So your dot product is the length of u times the length of v cosine theta, and it can also be written as AC plus BD. So make sure you read over that page again and make sure you've got that down. Now, how does that help us? Well, if we have the vector and we need to know the angle between us, well, now we can figure out what the angle between it is. because we can, if we have just the vectors, we can get their lengths, and we can have AC plus BD to figure out what the dot product is, and that'll give us the ability to find the angle between those two vectors. So, for example, let's see, if we have W is 4, negative 3, and V is negative 2, 5, then the dot product of the two is the real parts multiplied together plus the imaginary parts multiplied together, which gives us negative 8 plus negative 15, which is negative 23. Now, how does that help us? Well, now we can figure out what the angle is between the two vectors, because if we have these vectors here, we've got W here, and then we've got V here, and we can figure out what this angle is between them. So we have our dot product, and we know that it's A times C plus B times D, but it's also the length of W times the length of V times the cosine of the angle between them. So we know it has to be negative 23. Well, we can figure out what the length of W is. The length of W is just the square root of 4 squared plus negative 3 squared, which is just 5. And the length of V, which is square root of negative 2 squared plus 5 squared, which gives us the square root of 29. So here we have 5 times the square root of 29 times the cosine of theta equals negative 23. So we just divide both sides by 5 times the square root of 29. And we get that the cosine of theta equals negative 0.8542. Now, how do we undo a cosine? Well, remember, the cosine is acting on theta. It's not multiplied times it, it's acting on it. So we have to use the inverse operation. So that means we use the inverse cosine of negative 0.8542. Now, whatever mode your calculator is, that's the answer it's going to give you. So if you're in degree mode, you'll get 148 degrees, or 148.67 degrees, which is the same thing as 148 degrees 40 minutes. Or if we do it in radians, you get 2.595 radians. So either way, it works. And if you look at this, you can look at the picture and you can say, you know, that looks about right, so I must have done it right, because that's an obtuse angle and it's getting closer to the 180 mark. So 148 degrees, that's perfectly reasonable for what this picture looks like. So that's how we use the dot product to find the angle in between. So let's try another one. What happens if we have U is 2, negative 3, and V is negative 9, negative 6. So we have these two vectors. We've got U, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Again, graph paper would be way better. So if you have graph paper, use it. So we've got these two, and we want to find this angle between. Well, we've got the dot product, which would just be the real parts multiplied together. Plus the imaginary parts multiplied together. So we have negative 18 plus 18, which is 0. And we know that we need the lengths. So the length of u is the square root of 2 squared plus negative 3 squared, which is the square root of 13. And the length of v is square root of negative 9 squared plus negative 6 squared, which is the square root of 117. And we know that our dot product has to equal the length of u times the length of v times the cosine of the angle between it. So did we really need to even know what these lengths were? No, because the lengths aren't going to be 0, so that means that our cosine of theta has to be 0. Well, when is the cosine of theta 0? When theta is 90 degrees, or pi over 2. So what this tells us is that this is a right angle. If your dot product is 0, then it is always a right angle. So if the dot product is 0, then you know the vectors are perpendicular. Or normal, or orthogonal, depending on which term you want to use. All three of these mean the same thing, that they meet at a right angle. So if your dot product is equal to 0, then you know that it's perpendicular, it's orthogonal. Let's try another one. What if we have v is equal to 6i minus 4j, and w is negative 3i plus 2j. So this is our different vector notation, but remember, it's just the same thing. We have v goes 6 in the real direction and negative 4 in the imaginary. So there's v. And then w goes negative 3 in the real and 2 in the imaginary. And so there's our two angles, so our two vectors. So we're looking for this angle theta between them. So we can use the dot product, which we take the real part times the real part plus the imaginary part times the imaginary part. And we get negative 18 minus 8, which is negative 26. If we want to find the angle between them, then we also need the lengths. So v's length is, if you calculate that out, you have the square root of 6 squared plus the square root of 4, or plus 4 squared, which is the square root of 52, which simplifies to 2 on the square root of 3. You should be able to do these by now. And the length of w, the square root of 3 squared plus 2 squared, so we have the square root of 13. So when we do our dot product, we have that the dot product, remember the formula, is the length times the cosine of the angle between them. So you have negative 26 equals 2 root 13 times root 13. So this multiplied together gives you 26. So when we divide by 26, we have negative 1 equals the cosine of theta. Well, when does the cosine of theta equal negative 1? We take our inverse here, but you should already know this one. It happens when theta is 180 degrees, or pi radians. If you end up here with the cosine of negative 1, or the cosine of theta equals negative 1, that means your vectors are parallel, but they go in the opposite direction, which you can see here. They're all along the same line, but they go in the opposite direction. Now remember, we usually orient our vectors with their tail on the origin, but vectors can move around all over the place as long as they have the same direction and the same magnitude. So that's why we say they're parallel, because we could move them and then have them parallel, but then they're in the opposite direction. Let's try one more. If we have u equals 5/2 I plus 3/2 j, and w equals 20I plus 12j, then we want to have the angles, we want to have the, and find the angle between them. So we've got u is about here, and then w goes way out, but it's like this, way out like that. So if we want to look at those, because we've got positive and positive, we want to find out what the angle between them is. We find our dot product. So we multiply the real part times the real part plus the imaginary part times the imaginary part, and we get 68. Then we use our lengths. We find the length of u is the square root of 34 over 2. If you need help finding these lengths, you need to come in and ask for some extra, because by now we should be able to do that pretty easily. So the length of w, you get 4 on the square root of 34. So when we set up our dot product, it's, remember, the length of one times the length of the other times the cosine of the angle between it. So we have 68 equals square root of 34 over 2 times 4 on the square root of 34 times the cosine of theta. Well, you can see if you multiply all this out, what are you going to get? You're going to get 68. So if we divide by 68, we get 1 equals the cosine of theta. Well, when does that happen? That happens when theta is 0. So when you get that the cosine of theta is equal to positive 1, they are still parallel, but this time they're going in the same direction because there's no angle between them. They're right on top of each other. So if your dot product is equal to 0, then that tells you that they're orthogonal or perpendicular. If you get down calculating and you have the cosine is equal to -1, cosine of theta is equal to -1, that means they're parallel, they go in opposite direction. Or if you get the cosine of theta equals 1, they're parallel and they go in the same direction. Otherwise, if those three cases don't happen, then of course you can just calculate it out and figure out what your angle is between them. Just make sure you pay attention to whether you're dealing with degrees or radians. It doesn't really matter for our purposes whether you use degrees or radians. Just remember, if you are using degrees, you need a degree symbol so that we know it's degrees. Make sure you've read this section so that we can go over it in class.